RoboLunch, VDMA RoboLunch. So the topic for today is Vision and AI for Robotics. And as always, we have three fascinating stories, three companies joining us today for RoboLunch. A few things to clarify before we start with the presentations. So RoboLunch is open to all. So we hope the presentations are not too technical. So it should be open for everyone, for robot enthusiasts, also for others interested in robotics and automation. So we hope you enjoy it, and please feel free to recommend the RoboLunch series. As mentioned, three exciting short presentations, 9 minutes each, and 4 minutes of questions and answers after each presentations. We look forward to questions. They are welcome, of course. You can either ask your questions in the meeting chat, or you can raise your hand and we will assign you to speak. As in all VDMA events, the VDMA compliance rules apply and the event will be recorded. Our program of today, Vision and AI for Robotics. My name is, by the way, Anne Wendel. I work for VDMA Robotics and Automation. I'm in charge of the Machine Vision division, and I'm excited to have three member companies joining today. So first of all, a warm welcome to the three speakers, Christian Fenk from Robominds, to Alexander Beck from inos Automationssoftware, and to Sami, Dahlman and Jyri Lukkala from Vaisto solutions. So let's start with the first speaker. So Christian Fenk is Chief Sales Officer at Robominds. Robominds was founded in August 2016. It's specializing in integrating artificial intelligence into industrial robotics. Robominds and Christian's mission: smart robotics for everyone. So together with end customers, they want to take robotics to a new level towards real automation, implementable and affordable for any size of companies. So Christian, very warm welcome. The floor is yours. I look forward to your presentation. And you have 9 minutes to talk about every robot needs a brain.
Perfect. Okay, then I guess I start. I'd rather share the right screen. That looks promising. So hi and hello from my side as well, and welcome to my small lunch break. Every robot needs a brain. The headline of this lunch break is Vision and AI Robotics. So I thought, okay, I'd rather start with the question, what is AI? And honestly speaking, I'm quite nervous because it's a strange feeling. I'm sitting here in my home office, talk to my screen, and I know exactly that now a big group of people is listening. So I do my very best to make it entertaining and show you the benefits of AI robotics. So let's start with the question, what is AI? Well, that's kind of a tricky question. I tried to make it simple and try to make it organized. So I thought, okay, a good approach would be Wikipedia. So I surfed Wikipedia, asked for artificial intelligence. And honestly speaking, this should be not supported reading action or supporting reading lectures. I drill it down to the mandatory sentence. At Wikipedia, you pretty fast come to an end, which is defined over here. It says, okay, the term is difficult to define because there's already a lack of a precise definition of the word intelligence. Well, still I'm here talking about artificial intelligence and can't even explain or define the word intelligence. So I thought, okay, let's make a shortcut. Let's ask our good friend ChatGPT. So I added the prompt, hey, ChatGPT, what is AI? Describe it in one sentence. And with the description of ChatGPT, it makes way more sense. I drill it down once more to the real deal. It says it tries to mimic human intelligence. And this is the core of it. And this is, by the way, the core of Robominds and our approach as well. So we try to mimic the human intelligence as well. So now I have the claim everything a human can do with a brain, eyes, arms, a neural network, and fingers in this case, a robot can do as well if you teach the robot the right skill. Skill is, by the way, a mandatory word, so please remember that for later on. If you now transform this picture of this human to a robot, we have exactly the same approach, but this time the brain is over here, the eyes are over there, and by the way, good news, a robot brain can handle more than one pair of eyes. We have the robot arm, we have, of course, the skills and the finger. Talking about skills, I now brought some skills with me. I will start with easy tasks and then let's make it complex step by step. So the easiest task, I guess, is load carrier handling. Well, if you now question yourself, why do we need AI for load carrier handling? That's pretty simple. I guess only if they are brand new, they look exactly like they should do. If they are used a couple of times, they change quite dramatically in shape and color and whatever. So, and this is, I promise, the only video I brought with me, because I'm not a huge fan of videos and presentations. But as you can see here, bringing in goods into a storage system, in this case a small AutoStore system, or handling small goods from outside of a storage system is more than possible, no matter of the shape of the box or the color of the box, due to the fact that we have a trained neural network which can solve this task. Okay, in the next step, we now make it a little more complex. Talking about palletizing, because I guess if you have visited one of the trade fairs the last couple of weeks, you have seen a lot of palletizing solutions. I have the theory that every pallet which is stacked by a robot, someone needs to depalletize them, and this is mainly done manually. Why is this mainly done manually? Well, that's due to the fact that after the pallet have had a traveling with a lorry one through the country, the stacking pattern is no longer the same, and usually you don't know exactly the dimension of the boxes. Thanks to AI, you can just place an arm. Same approach as you do for palletizing. You just add a brain and eyes to the system. You install a deep palletizing skill, and all you need to do now is teach a few points where to place the cardboards, and the rest is done by AI. So as you can see down here, the system does the segmentation of the parts. It circles back a pick position, and then depalletizing becomes simple. Let's make it a little more complex now. Let's start with random item object picking. This had been the holy grail for a long time. The cool thing about this is if you have a dedicated neural network, which is dedicated, trained for segmentation of parts and then grab them or do singulation with them, there is no need anymore to upload any CAD files or whatever. The pre-trained skills or the skills with the pre-installed knowledge are smart enough to understand not only the part itself, it also circles back the dimension of the parts and automatically orients the parts in the length axis. So with this approach, you can simply sort or solve tasks with almost no programming efforts. The last topic I brought with me as an example is out of hospitals and labs. So what we also do quite a bit with our approach is we sort a lot of blood samples, pee samples, and poo samples in hospitals and labs. Even if these containers are standardized, the standard have more than 1,500 different shapes and color patterns. Thanks to AI and a pre-trained neural network, it becomes pretty simple. All you need to do is place a rack next to the robot. The robot will automatically scan the parts and then sort them by color pattern and place them next to the right process. Oof, the clock makes me nervous quite a bit. Okay, then continue. Well, the idea of this, or so far understood, the idea of this launch is to inspire you to talk. And yes, the presentation will be handed out afterwards as a PDF. The idea of this launch is to inspire you and to open a dialogue and to ignite some lovely ideas about robotics. So I thought, okay, what is a proper next step? How can you now start with AI robotics? Well, the first step is already done. You informed yourself. So you invest your lunch break to listen to the speeches and gather some information about AI robotics. That's the first step. The second step is start a dialogue with the experts. In this lovely robotic lunch, we have a few experts. So the people will have a speech after me. They're well educated in regards of AI. Ask them, ask me, and we will find together a first application. After we found together a first implementation, we support you to implement that. And then congratulations, you started with iRobotics. So 5 easy steps. Okay, with the time is running, I would say I would love to have now this dialogue I was talking about. I hope I have had the chance to inspire you a little with my examples I brought with me, and I'm looking forward to your question. Thanks a lot.
Thank you, Christian. That was right. Perfect in time. We have now time for questions. Let me check in the Q&A session. There is one question, and maybe I'll read it out to you. So, do I always need to train the robot system to the environment, or can it work out of the box with your models already, e.g. item picking, order fulfillment? So, Christian, how is it? Do we need to train your robot?
Well, that's a wonderful question, and thanks a lot for that. In our case, and therefore a different company follows different approaches. In our case, the brain comes with pre-installed and pre-trained neural networks, which fits for your tasks. So we have a so-called skill set we can cluster down for different tasks. We do an application check on site. We check your parts, we check your goods, we support you to choose the right gripper. And then usually we have pre-trained neural networks. So if I take the container of my earpods, for example, I know exactly this would be bulk medium size. So everything between this part and that part would work easily and is already pre-trained and out of the box ready to use. If there are shapes and parts we have never seen before or whatever, it's easy for us to retrain a neural network. And of course, we can retrain the neural network after time installed. But the parts, the brain is pre-trained, the skills are ready to use, because I can't sell you a brain with no knowledge at the beginning and hope for the best that it will learn it after a while.
Thank you, Christian. Are there any other questions? So this time at RoboLunch, you may also ask your question orally. So if you would like to discuss with Christian, feel free to raise your hands and I will assign you to speak. I do not see any raised hands, but I see another question in the meeting chat. So, Christian, does the robot get a point to move to? Does the robot get a point to move to or a complete collision-free path? What kind of collisions are avoided? Only bin or others?
It depends on the skill and it depends on the approach. So if, for example, in this case where we handle blood samples, of course, we do a full collision detection. We even have the fingertips of the gripper inside the model. If it's in bulk situation, of course, we detect the collision possibilities with the bin itself and stuff like that. So yes, that's part of it. And we are responsible from the moment you enter our workspace, which is the yellow space, till to the point you leave our workspace, which is the yellow area. For the rest, it's just a regular robot programming to make it as smooth and easy to integrate as possible.
Thank you. And another question is in the meeting chat. What if a task requires a new skill that is not yet available? What do you do as Robominds?
That's therefore we have multiple approaches, and especially when it comes to automation of warehouse systems where we have thousands of parts, there are always some shapes we'd rather retrain. There are multiple ways to do so. One way is that we collect real data with our system. So we pre-install a vision system on our case, which just collects data, and then we retrain it on our servers. Another possible way is that we can use artificial data we create on our own to retrain the process, which is very fast and very cost efficient. So there are multiple ways to do so. And a retraining is usually recommended to be just more precise and more robust.
Thank you. So I see a thumb up. So that means the question was dealt with perfectly. Thank you. I see another question in the meeting chat. Where do you get the pre-trained neural networks? And how many pre-training is necessary before it's installed?
Oh, a lot of heavy questions for a lunch, but I kind of like it. Well, as Anne mentioned in the intro, Robominds is for AI robotics quite an old company. So we do this now for a long time. So you can imagine that we have a huge data set in this regards, due to the fact that we can train artificial data in our own environment. We are pretty efficient and pretty fast in this regards, and we have a whole structure built up in our company to train or retrain data points. So therefore, there's always a limit, but there is nearly no limit in this regards. And the pre-trained skills, we have a huge library of pre-trained skills we can choose from, and then it's with the library we can solve a lot of tasks, and with the last 20% is then retrained with real data from customer projects.
Okay, thank you. Thank you, Christian, and thank you to all the active members of RoboLunch. I fear your time is up. Thanks again for opening the floor and for sharing your view at the transformative role of vision and AI in robotics.
It's been a pleasure, and best of luck for the next speaker.
Perfect. So my next speaker is coming from inos. So hello, welcome, Alexander Beck. Alexander is Chief Operating Officer at inos Automationssoftware. inos was founded in 1997, so in the last century. So it's a well-established and renowned specialist in robot vision technology and automation solutions. And inos, as a full service provider, focuses on integrating robotics and machine vision to optimize processes across various industries. And currently the focus lies on automotive and logistics. You do a lot with these end customer industries. And since 2012, inos has been a member of the global Grenzebach group. So also there a lot of knowledge, and Alexander is here to share applications examples with us, applying vision and AI for weld seam and surface inspection. So Alexander will focus on what difference AI brought to robot vision. So Alexander, welcome, and the floor is yours. You have 9 minutes to share your view.
Thanks a lot, Anne, for the introduction. Also, thanks everyone for coming. I hope that you have a great lunch and learn something about how vision and AI can be combined for inspection systems. First of all, why are self-learning inspection systems are even needed? Can't you just do it manually? Yes, of course. So also manual inspection systems are used in the industry, but of course they bring challenges with them. Examples is that there's a manual feedback loop between inspection, analysis, and then of course the production optimization. So everything needs to be done by hand. In comparison, when you have an inspection system that also uses AI, you have an automated feedback loop. So you inspect the parts automatically, and then the operators can provide feedback, and that generates a self-learning system through AI. And that results in faster process optimization and, of course, quality improvements. Manual inspection systems, I mean, we are all humans, and of course, there's inconsistent quality because it's a subjective visual check. And in comparison with an automated system, AI will apply standardized methods across all of the parts and shifts. Manual inspection can also be slow and resource intensive. And in comparison, if you have an inspection system that uses AI, you have most of the effort beforehand, but once it's developed, it can be used at scale and full production speed with minimal effort. Documentation and traceability is, of course, always challenging when it's done manually. And in comparison, of course, with an automated system, everything is logged, categorized, saved, and can afterwards be transformed. Like you can transform the data into information. So in summary, an AI-powered vision systems will offer adaptability. This is very important. So it's self-learning and improving. It has high quality and consistency. So we use AI not only for the detection, but also for the data augmentation to have higher quality and effective models to detect the defects. And we gain insight. So that means we turn quality data into process knowledge. What are we doing? We are experts in vision and AI for over 25 years. We focus on inspection systems, but also a lot of robot guidance systems, and also in the logistics for depalletizing systems, what you have seen in the presentation before. We are a global partner for automation and are active mainly in Europe, but also in South America and a little bit in Asia. So now coming to the two systems, we start with the weld seam inspection, but the process for the surface inspection is also very similar. So where do we start? We make a 3D scan of the part. Afterwards, we detect the defects. You will also see all of this in the slides that follow. And then the user can provide the feedback. And based on the user feedback, the detection model will improve. And then, of course, comes the next part. You do the scan, you detect the defects, you can give feedback. And so it's really a self-learning system that improves by itself. So we are starting here from the 3D scan. So here you can already see we draw the weld seam on the CAD from the end customer. So basically we scan similar to the robot shown in the presentation before, with the vision system, all of the weld seams, and then we draw it on the CAD because it's way easier for the operator to understand where the different defects lie. And now we would focus, for example, here on this area, and then we want to know more information about it. And this one you can see here on the left side. So you can see the different kind of defect types found here, for example, spatters or undercuts. You can also see the length and the heights of them, and also the status. So now we focus here on this one, number 2, and you see it's passed. That it means it's within the tolerances defined by the customer. And if we want to see more information about it, we can click on it, and then we go into a more detailed view. Since it's in 3D, you can also move it around as you're used to, for example, in 3D PDFs or so. You can zoom around, you can zoom in and inspect the defect in more detail. And then you can also provide feedback based on this review here. It would look like this. So you can say if it's a false defect, true defect, or unknown. And based on this user feedback, the system is improved. Here's also the live scan, of course. Once the robot scans all of the weld seams, you can also view it in a live scan and then already see the defect. So you see it's here scanned, and then you would already see it in 3D and also then the defects. Afterwards, we provide the customer also with an analysis, and that he can use to derive production optimization. So he knows his process is the best. And here, for example, on the right side, you have a density plot where you can see the amount of defects. And on the left side, different kind of graphs to show, okay, how many found defects are passed, meaning with intolerances, how many are repairable, and how many are non-repairable. Then it's also categorized here per different kind of defects. So the end user can very quickly see where the defects lie and then optimize his processes in the long term. The surface inspection is very similar to the weld seam inspection, so I will go faster through it. For surfaces, we can detect defects in different kind of surfaces. There can be flat or complex, shiny or matte, pointed or raw material, opaque or transparent. And the type of defects that we can detect can be either of structural nature, like scratches, dirt, or foreign objects, or textural, like discolorations, waves, or missing patterns. How would this look like? Here's an example. So we scan the part. We also use illumination to detect the defects better. And then afterwards, we will have the results. So you see it is very similar to the weld seam inspection. You can see all of the detected defects here. And on the left side, it's structured by defect type. You would also have more details. And then here you can also see on the status, here are some irreparable defects. And that's why it's also marked as red. Of course, you could zoom in, you could give a review, and based on that, provide the feedback. So in summary, we combining vision and AI enables adaptability. So it's self-learning systems through AI. They certainly provide a much higher quality and consistency. They are scalable and they provide the customer insight. So we turn the quality data into process knowledge. Thanks a lot.
Thank you, Alexander, for sharing your view and your insights and for digging into weld seam and surface inspection in the automotive industry. That's great.
Thanks a lot.
We now have 5 minutes time for questions, and I would like to open the floor. Let me check in the chat or in the Q&A part of the chat if there are any already. And of course, feel free to raise your hands if you would like to discuss or raise your question orally. Nothing in the chat so far, so let me ask a question. You also mentioned logistics.
Yes.
So what are the typical tasks in logistics where you apply AI and vision?
So in the logistics area, it's actually very similar to the previous shown presentation. So there we have also depalletizing systems, mainly focusing on the KLT boxes, but we also have bin picking solutions. So there we use AI to improve our models for optimal detection and having high quality and high consistency.
Thank you. And I see a question in the chat right now. What kind of sensors do you use for weld seam and surface inspection?
So for the weld seam inspection, we use 3D sensors. I don't want to make product placements here, but it's knowable sensor producers, I guess we all know here. Certainly 3D sensors, but for the surface inspection, we use 2D sensors. And for the palletizing, we also use 3D sensors.
So 3D and 2D sensors, perfect. Thank you. Let me check the other chat. Yeah, so what pre-trained neural network do you use and how many pre-training is necessary if you go into a new application, a new customer?
Okay, there I would need help from my technical colleague.
Okay.
Please also in the chat, maybe Vasilis can raise his hands, then he can explain this one. He raised his hand.
Yeah, here he is. So Charlotte, could you please unmute Vasilis? And Vasilis, please.
Hi from
Yes. Sorry, we have you are muted right now. Let us unmute you. Yeah, now we can hear you. Perfect, Vasilis.
Thank you. We are using deep neural networks that combine convolution with some other types of layers, and the end result is basically a nonlinear classifier. And how do we train it? We've trained on concerning cult and pin picking. We've trained on a large number of samples in our lab, and we also support virtual training using CAD. And we also use a number of, let's say, more traditional machine learning techniques that combine clustering and classification with non-modern AI methods. We found out that it's more robust.
Mm-hmm. Thank you, Vasilis. And I'm sorry, time is over. So Alexander and Vasilis. Vasilis, I guess you are from Greece, joining from the team in Athens. So welcome also. Yeah. And thank you for joining in and for sharing your expertise with us. That's great. So we have a third company with us today, and I would like to move on to our next speakers. So our next speakers are Sami Dahlman and Jyri Lukkala. Sami is CTO and Jyri is machine learning expert, and they come from Finland. They work for Vaisto Solutions. Vaisto Solutions was established in 2017 and is headquartered in Tampere. Vaisto Solutions specializes in software engineering services for smart connected machines and industrial automation. And the Vaisto solution team, they assist clients in developing innovative products through software-driven solutions. And with Vaisto, with Sami and with Jyri, we are now digging into mobile robotics. You brought perfect application examples where you talk about sensor fusion for the mixed fleet era. And I'm now looking forward to your expertise, to learning what vision and AI brings into mobile robotics. So Sami and Jyri, the floor is yours, and yeah, thank you for joining.
All right, thanks, Anne. Let me start sharing. Hopefully this is shows fine. So yeah, welcome to RoboLunch on our behalf as well. So my name is Sami, and I have with me here Jyri from this sensor fusion project actually. And as mentioned, our presentation topic today is this sensor fusion for mixed fleet era. You can see in the picture kind of hint of the machines that we are dealing with. So let's move ahead with this and you will hear more. So our presentation covers the collaboration between Kalmar and Vaisto related to sensor fusion development. As Vaisto was already introduced by Anne, I'll only say a few words about Kalmar now. So Kalmar is a global company focused on providing sustainable and efficient cargo handling solutions. Their mission is to be a forerunner in the industry by offering equipment and services that improve their customers' safety, sustainability, and productivity. Kalmar's product range includes a wide variety of heavy material handling equipment such as terminal tractors, reach stackers, forklift trucks, straddle carriers, and container handlers. They also offer automation and robotic solutions, as well as comprehensive parts and services to support their equipment through its life cycle. So our presentation touches this specific automation and robotic solutions area of Kalmar. So today, these Kalmar carrier, straddle carrier autostrats, like the one you see on the left side in the picture, are executing already autonomous container operations in enclosed unmanned areas. These fully automated container yards are viable in large and busy harbor areas, but in smaller harbors, we need a more elastic approach. So to broaden the possibilities for autostrats to operate more flexibly in harbor areas, the localization and perception methods must be enhanced so that other machines and road users can be detected reliably on all weather conditions. In this project collaboration, we had only a small team from Vaisto side, 2 persons, specialist of machine learning and also kind of a work machine domain specialists. And on the Kalmar side, they were of course the kind of product owners on their sides, and they involved also kind of domain specialists in the project. And they were providing the facilities for data collection and of course feedback about the results. So project target was to develop sensor fusion model for straddle carrier based on state-of-the-art algorithms from the industry. The method has to support the operation of multiple LiDARs and camera pairs operating concurrently and in real time. Target was to ensure that safe and reliable perception is able to detect both static and dynamic obstacles and target objects. So in the harbor areas, the objects can be, for example, of course, the containers, trucks, humans, and of course, many other kind of dynamic objects that could be there in the area. Okay, then a few more words about the sensor fusion itself. So there we combine the data from multiple sensors to produce more accurate, reliable, and comprehensive understanding of the environment that could be achieved by only using a single sensor alone. Sensor fusion itself can be achieved by multiple ways, ranging from this traditional late fusion that you can see on the left side summarized, where the detection is performed independently on each sensor first, and then the detection results are fused together after that to be used for example, control action planning. We used in our research the state-of-the-art deep fusion, where all sensors are, of course, time synchronized and calibrated together, and they input data to be processed in a common neural network model that fuses the data to perform the detections in optimal way. In the research project, our target was to select the best fitting deep fusion algorithm for the LiDAR and RGB camera data, ensure the fitness for Kalmar's use cases, and speed up the development by using synthetic data for early validation. Once the fusion method was proven functional for the use cases, then our focus moved to improving accuracy, scalability, and performance. All right, but then over to you, Jyri.
Yeah, thank you, Sami, and hello everyone, also on my behalf. The most suitable method after our paper review and quick prototyping ended up being this bird's eye view fusion, or BEV fusion for short. It's developed by MIT, the research team. And this model supports LiDAR, RGB, and radar data sources, and it provides a bird's eye view based on the fused sensor data, and it supports multi-class detection and trajectory estimation. And here we have some examples of the BEV fusion method in action. So in these next images, on the left side, we have the actual BEV fusion, the bird's eye view. So looking from the top, and we see these different boxes, and the different colors mean different classes or different categories of objects. And on the right side, we have this RGB image, where we have these detections, these 3D bounding boxes shown as an overlay. And these are already like quite accurate here, but of course, when we train more, then they can become more and more accurate and reliable. And here we can also notice that even from a long distance, we can still detect this open door as a separate detailed object. That was one of the use cases that our customer wanted. And here's another example, a little bit closer, where we have these stacked containers detected, and also a human, which is only barely visible, but it's still being detected by the model. And here we have another example where we have different vehicles also, and one human detected. And in this example, actually, the rotation of the car was kind of inaccurate, but that was due to our limited data set. So we had only like a smaller data set in this training, so that's why the orientation wasn't perfect. But then later on, when we added more data, then that will improve. And then as a last example, we actually have a short video sequence of these detections. So this is the inference what the machine will see with this BEV fusion. So we see these detections. Then of course, when we go closer, then some of the objects come kind of they are out of the view for the slider. So then when you go close enough, then the detections are not so reliable. But with the perfect distance, then we can see the objects clearly. And then, like I said, when we train this a little bit more, then the fusion of LiDAR and RGB camera works better, and then we can see also this like a closer object a little bit better. So like partially occluded objects are of course difficult, but that's why we actually introduced this BEV fusion, because we want to kind of combine the best qualities of the LiDAR and the camera. And then this is our last slide actually. So our conclusion is that this BEV fusion method is a powerful method for building enhanced perception systems that are accurate and also ready for adverse conditions, of course, depending on the selected sensors. And this method is applicable for autonomous driving, robotics, and perception solutions in general. And together with the synthetic data and simulation, the deep fusion system development can be sped up and used to implement complex perception systems in the mixed fleet era. So that's about it on our behalf.
Right. Yeah, thanks, Jyri. Any questions at this point? And over to you, Anne.
Yes, thank you. That was really exciting to also see like how robust your AI vision system is working. I mean, I saw snow, I saw sun, so it's pretty robust, your system. Perfect. Congrats. So I see a question in the meeting chat. I see two questions. So one to you. Don't you think that the accuracy is not sufficient for robotics applications?
Well, at this point, we are still in the R&D phase, so this is not ready for production. Let's be honest. But we are collecting more data, and we are also like adding this synthetic data where we can take different lighting conditions and different weather conditions into account, and then when we combine the synthetic data with the real world data, then we can develop this to be robust enough for actual production.
Right. And just to comment the kind of robotics part. So as we know, robotics can operate in very kind of different kind of environments and contexts. So basically, it's like comes down to this like a sensor selection as well. Basically, if you are indoors, for example, and then the kind of details of the sensors, how accurately you have to measure things, and then it's of course, as Jyri mentioned, comes down to the data set and the techniques to train basically the kind of model. These are in many cases like the algorithms to be used slightly, of course, environment specific. At least the parametering changes. But yeah, good question, definitely.
Definitely, thank you. And there's one question. You also mentioned synthetic images, yeah, that you use synthetic data for training AI models. So it's a question to Kalmar, to Vaisto Solutions and to all speakers. What experience do you have with the use of synthetic data for training AI models? Where can it be used and where not? What are the limitations?
Yeah, well, that's a great question, and we actually have very good experiences of the synthetic data. It sped up our development quite a lot because like many of you may know, but like acquiring usable data for the training of the neural network, that can sometimes be like the bottleneck. But when we have this like synthetic data set asset, we have this like a 3D environment of a container terminal where we can model everything, the containers, people, trucks, and other vehicles. So we can vary everything there. So we got that as a starting point for the training. And then of course we can't fully forget the real world data. So its best way is to combine the synthetic data and the real world data. And yeah, so far our experiences are really good, but of course it requires that you must have the capability of simulating your environment.
Right, and again, small comment. So basically, especially in the early phase, like Jyri said, that we cannot start the development by using only synthetic data. It was also kind of matter of selecting the right method in the first place. So we can kind of verify the algorithm itself by using only synthetic data. But overall, in the end, our experience is that, of course, you need kind of a lot, at least today, kind of you need a lot of this real data as well. But the research results show that in many cases anyway, the model becomes better if you mix synthetic and real data instead of using only real data. So that's also maybe an interesting result. But it really depends on the use case then, that what is the like a split between synthetic and real data.
Okay, so I fear time is over. Thank you, Sami, and thank you, Jyri, for showing us what is already possible and how you bring vision and AI to ports, yeah, so to logistics and ports. So thank you, and also
Thank you.
Again a big thank you to the other two speakers, to Christian and to Alexander. So thank you for sharing real world use cases. I mean, we hear a lot about AI, yeah, but here we saw real world use cases, and you showed your experience with us. You shared your experience with us. So thank you. And thank you also for showing what transformative role vision and AI brings to robotics. And I guess there is a lot of potential to even more. So well done. Thank you. Thank you all for joining. And of course, we would like to get your impression. What was good? What could be improved? Your view on new, exciting topics that you would like to listen, company examples about. Please let us know. Give us feedback. And as I mentioned in the chat, we are going to share the PDFs of all presentations. And I really would like to encourage you to get in touch with the speakers. You will find the contact details at the last slide of the PDFs. So also, if we couldn't deal with one question from the meeting chat or two, please contact the speakers. They are here to discuss with you. Perfect. And before closing, RoboLunch, VDMA RoboLunch is a series. So we already have our next topic, and next date is going to be in September 16th. Again, we will have 2 to 3 exciting application examples, companies that share their views on humanoid robots. So please mark your calendars, save the date, and join us again in September for VDMA RoboLunch. So thank you and have a great day ahead of you.
Right.
Thanks a lot.
Thank you. Right. Bye-bye.